Hello guys, today I'll be explaining the physics AMS of term 1, week 8. So let's start. A group of students are investigating the law of moments. They put a uniform meter stick. Whenever they tell us we have a uniform object, that means the center of gravity means from where the weight comes, okay, is at its center, at its geometrical center or at its center. They put a uniform meter stick. Meter stick means that it is 1 meter or 100 centimeters on a fulcrum and suspend two masses on it. The fulcrum is at the center of the meter stick. Mass 1 is 200 grams and is located 30 centimeters away from the fulcrum. And the other mass 2, can be varied and suspended. They told us use G is 10 meter per second squared. They want us what? They want us to find the combinations that will balance the meter stick. For the meter stick to be balanced, the anti-clockwise rotation or the moment of the anti-clockwise has to be equal to the moment of the clockwise. So, if we're gonna do it, we're gonna label it as moment 1 or moment clockwise is equal to moment counterclockwise. So the moment clockwise, we can say moment 1, for example. Moment counterclockwise, we can say moment 2, for example. So moment 1, we know that moment is equal to force times distance. So moment 1 is equal to force 1 times perpendicular distance 1 is equal to moment 2, which is force 2 times perpendicular distance 2. Here, if you're gonna be looking for the force, the only force here is what? It is the weight. So the weight, the rule for the weight is mass times gravitational force. So we can substitute the forces by mass. So it will be mass 1 times G, because G is always the same, times perpendicular distance 1 is equal to mass 2 times G times perpendicular distance 2. G will cancel out with G, and so then you will get a final equation which is m1 times perpendicular distance 1 is equal to m2 times perpendicular distance 2. If you go up, they told us, actually it's not mentioned, I don't know, I did not see if it's mentioned or not, but I believe that the stick is massless. Let's say the stick is massless. We're only focusing on these two weights. If they said that the stick is not massless, a totally different thing would happen. But now, let's imagine, because they didn't tell us the mass of the stick, we're gonna say that the stick is massless. If we're gonna apply the rules, we got mass 1 times perpendicular distance 1 is equal to mass 2 times perpendicular distance 2. Mass 1, we said, was 200 grams multiplied by the perpendicular distance 1, which was 30 centimeters, is going to be equal to mass 2 times the perpendicular distance 2. 200 grams times 30 centimeters is 6,000 grams times centimeter. But there's no need for the unit. So let's say now 200 times 30 is 6,000. Let me make these 0, okay? 6,000. So 6,000 has to be equal to the mass 2 multiplied by the perpendicular distance 2. So very simply, we can just try mass 1 multiplied by, this mass multiplied by this distance, we'll see, is it equal to 6,000? 150 times 40, it is equal to 6,000, so the first one is an option. Then 600 times 10 is equal to 6,000, so it is an option. Then 1,500 times 2 is not equal to 6,000, so it's not an option. 50 times 45 is not equal to 6,000, so it's not an option. 1,200 multiplied by 5 is equal to 6,000, so it is an option. So this, and this are options for to make the mass 2 times distance perpendicular 2 equal to mass 1 times distance perpendicular 1. Now question number 2. So what are the characteristics of the forces that form a couple? A couple is what? They are, for example, the force you need to open a water bottle. When you open a water bottle, you use 2 fingers. You put one on one side and the other on the opposite side. So if you notice, they are, when you turn the bottle, there is an equal amount of force being exerted by you on both sides of the cap. But if you notice, the direction is different. The direction of your fingers, if you want, are different. So you can do it with your fingers in both the directions, but it's most comfortable if you put your one finger going the opposite way and the other finger going in the opposite way. So if you notice, your fingers are in opposite direction. So they are also parallel as well. So if we're gonna apply what are the characteristics of forces that form a couple, we need to first understand what a couple is, then we can know what are the characteristics. The moment of the forces forming the couple is 0. This is totally wrong because you have to read the sentence very carefully and understand what they mean. The moment of the forces forming the couple is 0. So are you putting, for example, 0 force on your bottle and then it turns? No, this is impossible. However, if they told us that the resultant force or the net force of the couple is equal to 0, then yes, this is correct. So the first one is wrong. They are in the same direction. When you are turning the bottle, are you exerting the force? So let's say this is the cup. You exert one force going here, one force going here. And if you are gonna, let's say this is the axis of rotation. If you're gonna rotate, it will go like this and like this. So they are in opposing directions, but their rotation is the same direction. So you know that they are oppositely directed, but their rotation is in the same direction. They are parallel lines and they have equal magnitudes, but they are definitely not in the same direction. So for question number 2, it is they have equal magnitudes, they have parallel lines of action, and they are oppositely directed. Now question number 3. Consider two forces. This is a couple of forces, each of magnitude 15 newtons applied to a twist 2 centimeter cap as shown below. They need us to find the moment of this couple, okay, in newtons per meter. So they need the distance to be meter. We have our distance in centimeters, so let's change the distance from meter to centimeter. To change from centimeter to meter, you're gonna divide by 100. So it becomes 2 divided by 100. You will then get 0.02 meters. So now our distance is 0.02 meters. But they are asking us for the moment of this couple, not the net moment, so pay attention. They didn't ask you for the resultant force or the net moment. If they asked you for the net moment or the resultant force, you would put 0. Here they're asking you for the moment of this couple. To find the moment of any couple, you do force multiplied by the distance between the forces, between F's. So what's our force? Our force is 15 newtons multiplied by what? By the distance between this force over here and this force over here, which is 0.02 meters. So 15 newtons multiplied by 0.02 meters, you will get 0.3 newton per meter. Now don't forget, here they ask you for a moment. Anytime they ask you for a moment, you take positive. But if they asked you for the torque of this couple, you would do plus or minus. Plus if it goes in the anti-clockwise direction, and minus if it goes in the clockwise direction. Okay, so here they asked us for the moment. We don't need to use this. We're only going to take positive. So we're going to do 15 newtons, the force multiplied by the distance between the two forces, which is 0.02 meters. And so then we get 0.3 newton per meter. Question number 4. Two downward forces of respective magnitudes 50 newtons and x newtons are applied to a uniform plank of weight 20 newtons as shown below. The center of the plank is placed on the fulcrum and the forces are applied respectively 25 centimeters and 40 centimeters from the fulcrum. So keep in mind that the weight of the plank is 20 newtons. Now they're asking us, what is the magnitude of x? We know that if the plank is balanced or in equilibrium, then the moment of clockwise is equal to the moment of anti-clockwise or counterclockwise. That means what? Moment 1 is equal to moment 2. So force 1 multiplied by perpendicular distance 1 is equal to force 2 multiplied by perpendicular distance 2. What's our first force? Our first force is 50 newtons. We multiplied by the perpendicular distance from what? From the axis. So multiplied by 25 centimeters is gonna be equal to force 2, which we need to find, multiplied by the perpendicular distance, which is 40 centimeters. Okay? So if we're gonna solve it, you're gonna get that force 2 is gonna be equal to 50 newtons times 25 centimeters over 40 centimeters. So 50 times 25 over 40, we will get 31.25, which is approximately 31 newtons. So we have the value of force 2, F2, which is 31 newtons. Now this is very important. They need the upward force exerted by the fulcrum on the plank. You should know that the the force of upward is equal to the total forces of downward. How do we know? Because the plank is in equilibrium. We make sure that the plank is in equilibrium. If the plank is in equilibrium, then the force exerted upward is equal to the total force exerted downward. So let's take all the forces. This is why I told you pay attention for this one, the weight of 20 newtons, because we have 20 newtons as a weight downwards. This is an additional force. Here we have it as 31 newtons. So the upwards force is equal to 50 newtons plus 20 newtons plus 31 newtons. If you do it on your calculator, you will get 101 newtons. So the upward force exerted by the fulcrum keeps it what? It keeps it in equilibrium. Alright? The fulcrum, of course, is exerting an upward force to keep it balanced. This upward force to keep the plank balanced has to be equal to all the downward forces. They didn't put for us weight, but they said in the question, that we had a weight of 20 newtons. So 50 newtons plus 20 newtons plus 31 newtons, we got 101 newtons. So now, select the picture that represents forces forming a couple. Two forces that form a couple must be equal in magnitude. Opposite in direction, they must be parallel but not coinciding. Coinciding means they will not meet each other at any point. So, and the resultant force must be 0. So first thing we need to know, they have to have the same magnitude. Okay, they're equal in magnitude. Definitely this one is wrong because it doesn't have the same magnitude. Everything else is correct because they have, so far is a possible answer because they have the same magnitude. Next thing, they should be opposite in direction. Definitely this one isn't opposite in direction, and definitely for sure this one isn't opposite in direction. So we're left with this and this, which are two possibilities. Last but not least, they have to be parallel and not coinciding. This is not parallel, they are coinciding, so it's wrong. So it leaves us with this over here. This is a picture that represents forces forming a couple. Now, the point at which the entire weight of a body is assumed to be concentrated is called the center of gravity. In uniform objects such as a square, a rectangle, a triangle, a circle, the uniform object, or for example a stick, okay, the uniform object is, the center of gravity of these uniform objects is at the center. So that's why it will be drawn like this. So from the center of these objects, they will draw the center of gravity. Now question number 7. I just discussed about what? About the uniform objects, how to find their center of gravity. It is their geometrical center, or their midpoint, or their median, whatever you want to call it, okay? So if we are using an unusual shape, an unsymmetrical, a shape that's not uniform, okay, then we use something called, I don't know what it's called to be exactly, but it's like a test to do it. So what do? You place your ununiform object, you place it on the wall, okay? It should be vertically, okay? Then you take what? You take anything that dangles, okay? Like a straight line, for example, for example, a rope, and you put a weight in the rope. Then you hold the rope, okay? You wait until the rope stops moving. Then what do? You draw a line. So for example, this is our rope. The rope has a weight at the bottom. We wait until the rope stops moving, and then we draw a line. Then we turn the uniform object, for example, a paper, we turn it around again, and then we do it again. So let's say it was straight up this time, and then the lamina would go like this. The object, would go like this, the object with the weight. You would notice that if you draw the line, it will be passing through O. So then we can say that O is what? O is the center of gravity. So for uniform objects, you do this method, okay, to get the center of gravity. Sorry, for ununiform, not for uniform. For the objects that are not uniform, you do this method. So sorry guys, my internet reconnected, so that's why my quiz looks like the time is different. But no, it's the same quiz, don't worry, okay? A boy of mass 60 kg sits on the seesaw beam at a distance 0.8 meters from the pivot as shown below. His friend of mass 40 kg balances the beam by sitting at a distance x from the pivot. Drag and drop from the box below the value of x. We said if it is balancing, where is it? What does it say? She balances the seesaw. If it is balancing, then the moment of clockwise is equal to the moment of counterclockwise. Then again, we said that we will say this is 1, this is 2. So force 1 multiplied by perpendicular distance 1 is equal to force 2 multiplied by perpendicular distance 2. Our force in this case is the weight, so the weight is equal to m times g. So then we have mass 1 multiplied by g times perpendicular distance 1 is equal to mass 2 multiplied by g times perpendicular distance 2. So what do we get now? We get that we can cancel g here and g here, and then we get mass 1 times the perpendicular distance 1 is equal to mass 2 times the perpendicular distance 2. So it becomes 60 kg times 0.8 is equal to 40 kg times x. So 60 times 0.8 is equal to 40 times x. Okay? If we do it on our calculators, we get here 48 is equal to 40x. Then divided by 40, you will get that x is equal to 1.2. So she needs to sit at a distance of 1.2 meters away from the fulcrum, which is this over here, so that the seesaw will balance. Question number 9. A massless, very important to pay attention, massless, there is no mass, seesaw of length 100 centimeters has 2 people of masses 40 and 60 kg sitting on its opposite end. So let's draw. If you draw, it will always help you. We have a seesaw like this. Okay. And we have its fulcrum over here. We'll not say that it's exactly in the middle, okay? It's over here. So we have a person of 40 kg. She sits here, for example. And then a person of 60 kg, he will sit over here, okay? So we know now that this guy, his mass is 60 kg. And this girl, her mass is what? Her mass is 40 kg. We know that the total length of the seesaw is what? 100 centimeters, okay? We need to use g is 10 meter per second squared. Again, we said the center of gravity of the system. To find the center of gravity of a system, to find it, we need to know what? We need to know that the moment of clockwise has to be equal to the moment of counterclockwise. So if you're searching for the center of gravity, then the moment of clockwise is equal to the moment of counterclockwise, okay? So, again, we'll label this one, label this two. This is force 1 multiplied by perpendicular distance 1 is equal to force 2 multiplied by perpendicular distance 2. Here what the force we're talking about is what? It is the mass. So weight W is equal to M times G. So mass 1 multiplied by G times the perpendicular distance 1 is equal to mass 2 multiplied by G multiplied by the perpendicular distance 2. We cross G and we cross G. We are left with mass 1 multiplied by perpendicular distance 1 is equal to mass 2 multiplied by perpendicular distance 2. Okay? So, we don't know what is the perpendicular distance from the person to the fulcrum. So we will call this, for example, x. If this is x, okay, then the distance from the boy to the center is going to be 100 minus x, because we know the full thing is 100. So if this over here is x, then this is going to be what? This totally is going to be 100 minus x. So if we're going to substitute, we have the equation mass 1 times distance perpendicular 1 is equal to mass 2 times distance perpendicular 2. We know that the mass of the first person is 40, and we called the distance perpendicular x because we did not know what it is. Then the mass of the second person is 60, and we called the second distance, the second perpendicular distance, 100 minus x, because again we didn't know what it is, but we know that one is x, so this one will be 100 minus x. Okay, so it becomes 40x is equal to 6,000 minus 60x. If you bring 60x to the other side, you will have 60 plus 40, which is 100x, is equal to 6,000. Okay, so now here's another 0. So then x is equal to 60. So the distance is what? 60 centimeters. So the center of gravity is located away from the 40 kg person. We found x. The center of gravity from the 40 kg person is what? 60 centimeters. But if they asked you from the 60 kg person, it will be 100 minus 60, which is 40 centimeters. But they asked us for the 40 kg person, so it is x, which is 60 centimeters. Now, they are required by the force exerted by the fulcrum on the seesaw. If you remember, this is our seesaw, okay? This was the fulcrum, for example. We have the girl over here in pink and the boy over here in blue, okay? We know that the girl is exerting 40 kg and the boy is exerting 60 kg. And the fulcrum is also exerting a force that we don't know, that we need to find. So what are we going to do? We're going to do that the up force is equal to the total down forces. So what's the down force? The down forces are weight in this case. To find the force of weight of this person, it's going to be 40 times 10, which is 400 newtons. This, to find the force, it is going to be m times g, which is 60 times 10. You'll get 600 newton. So the up force is equal to 400 newton plus 600 newton. So then the up force is what? 1000 newton. So that's how we get 1000 newton. Question number 10. A group of students are investigating the law of moments. They put a uniform. Uniform again means what? Means that the center of gravity is exactly in the middle. It is exactly at the center. Meter means it is 100 centimeters, or basically 1 meter. Stick on a fulcrum and suspend 2 masses from it. The fulcrum is at the center of the meter stick because why? It is uniform. So if it's at the center of the meter stick, that means the fulcrum is at the center of gravity. Okay? One of the weights attached to the meter stick is equal to 2 newtons. The other weight, W, is unknown. What we're going to do over here is that we're going to say the stick is massless because they didn't give us a mass for the stick, okay? So right now, we're assuming that the stick is massless because there's no mass given of the stick, okay? So we know that the weight exerted on this side is 2 newtons. And we know that the weight exerted on this side is W. We have the distance here is A and the distance here is B. So now, they are asking, the students detect the distances to the fulcrum A and B that keeps the weight balanced. Balanced means that the moment of clockwise is equal to the moment of counterclockwise. Okay? So, they're asking us to find the slope of the graph, we're gonna do basic math. We know that the slope is y1 minus y2 over x1 minus x2. If you do it, let's take any 2 points, for example, this and this and this and this. You will do then 0.15 minus 0.3 over 0.1 minus 0.2. And you will get that the slope is 1.5. So the value of the slope of the graph is 1.5. The unknown weight is, if you notice, if you look back at the graph, it says what? It says A meter, B meter. And do you notice a relation? We found the slope, so the slope is 1.5. That means x, the x-axis, multiplied by 1.5 will give us the value of the y-axis. Look again, for example, 0.4 times 1.5 gives us 0.6. Then 0.25, it's not an exact value. 0.2 times 1.5 gives us 0.3. Okay? So now they're asking us for the unknown weight W. Anyways, I forgot to mention that we can make it a rule. If this is x and this is y, we said that x multiplied by 1.5 is equal to y. So then we can say that A times 1.5 is equal to B. So if we go up, we can substitute B by A times 1.5. So now we have 2 newtons, which is, first of all, we have moment clockwise is equal to moment counterclockwise because they are balanced. Okay, so we're gonna write the equation, which is force 1 multiplied by distance perpendicular 1 is equal to force 2 multiplied by distance perpendicular 2. Our first force we have is 2 newtons multiplied by the distance, which is A times 1.5. It's equal to the second force W times A. We have A on both sides, you can cancel A and A, and so now you have 2 times 1.5 is equal to W. So then W is equal to 3. So if we go down, we know that unknown weight W is equal to 3 newtons. So that is it for question number 10. Now question number 11. This is like the one I explained. Given a uniformly thin flat object of irregular shape, meaning it is ununiform. Here, uniformly thin does not mean it has a uniform shape. It should have a uniform shape, not the thin or thick. So we need to arrange the steps in order to find its center of gravity. We said to find the center of gravity of an irregular shape, for example, this shape. What we're going to do is that we're going to suspend it vertically. So we're going to suspend the object from a fixed point and allow it to set at an equilibrium position. Take a paper, for example. Cut a paper in an irregular shape. For example, like I did now. Stick it on your wall. You will see that hold it from the very top. You will see that the paper starts to fall until that it reaches equilibrium. So you suspend the object from a fixed point and allow it to settle in an equilibrium position. After that, what we're gonna do? We are gonna use a plumb line. So we're gonna take the wire, for example, or the rope with a weight. We're gonna put it vertically downwards on the object until it stops moving, until it stops swinging. So we're gonna use a plumb line to draw the vertical line. So this is number 2. Now number 3, you will do this many times, okay? Ouch. So you will do it many times until you get that the point of intersection of the plumb lines is the center of gravity of the objects. I think here they did do a mistake because 3 and 4 are switched, but they already gave us 4, so keep it like this for now. But if it was to come in the exam, 4 would be here, 3 would be here. Why? Because you have to repeat the procedure using several points of suspension. Then, where the point of intersection of the plumb lines, this is the center of gravity of the object. So in the exam, 3 and 4 are switched. Here, I think they did a mistake. I'm not sure. Question number 12 is one of the most important questions. It seems tricky once looking at it at the beginning, but once you know it, it will become the easiest thing ever. So please pay attention. A uniform meter ruler. Uniform means that the center of gravity is its geometrical center. Okay, the center of gravity is its geometrical center. Meter means 100 centimeters or 1 meter. Okay, now the ruler has what? It has a weight. So we're giving the weight of the ruler, which is W, 0.95 newtons. The length of AB, which is the length of the meter ruler, 100 centimeters, is supported on a knife. So it is supported on a fulcrum over here, which is the knife. The knife is placed at 45 centimeters from the meter ruler. Now this knife exerts what? It exerts a force upwards, okay? This meter ruler balances on the knife. So this force upwards is what is balancing the knife. It's balanced when a mass of 48 grams is suspended at a distance x from A. So let me repeat this again. Let me repeat it in my own words. We have the weight in the gravitational center over here. The weight of the knife is 0.95 newtons. So if we put the knife without anything, like the whole meter ruler is empty, it's just the plain meter ruler with the weight of 0.95. If we put it at the gravitational center, it would balance. But they told us they put a mass of 48 grams. So this over here, 48 grams, they put it at a distance x. They need us to find the distance x, okay? But us, we know what? We know that they put a knife where, they put a knife at the distance 45 centimeters away from point A. And when they put it there, then the ruler balanced, meaning with the additional weight, we moved the knife closer to A, and then it balanced. So I'm gonna write one rule that you guys know from before. You remember that the up force is equal to the total down forces. The up force, we're gonna call it force N. Force N is equal to what? It's equal to the total down forces. So it's equal to the force of 0.95 newtons. So I will put 0.95 newtons plus, so this is the weight of the ruler, plus the additional weight over here, because this is a force, no? It's a downwards force. So to find the weight given the mass, you're gonna do 48. You're gonna first of all change it into kilograms. So you're gonna divide by 1,000. Then you're gonna multiply it again by 10. So you will get 0.48 newtons. So it's gonna be the total upwards force, which is the force of N, is equal to the force of the weight of the ruler plus the force of the weight of the object, which is 0.45 newtons. Okay? So if we add it on the calculator, 0.95 plus 0.45, we are gonna get 1.4 newtons. So, my bad, this is 0.48. You see, I did a silly mistake. Guys, don't do like me in the exam and do the dumbest mistakes that you can avoid, okay? So it's 0.95 newtons, the force of the weight of the ruler, in addition to the force of the object downwards, the force of the extra weight over here, which is 0.48 newtons, you will get 1.43 newtons. This is the upward force, the force of N. Now we have 1.43 newtons is the upward force N. We have 0.95 newtons is the downward force weight of the ruler. Then we have 0.48 newtons is what? The downward, this is force, sorry. Then we have 0.48 newtons, which is the downward force, which is the weight of the block. Alright? Now, one more thing. They told us it balances. Balances means that the moment going clockwise is equal to the moment going counterclockwise. But I'm gonna change it a little bit, only in this case. If you remember, in previous cases, we had only two forces going downwards. We did not consider the one going upward. Well, now I'm gonna give you guys a new rule, which is that the moment of the upwards force is equal to the total moment of the downwards force. When we're talking moment, we're not talking about plus or minus, okay? So only if you have upwards and downwards do you use this rule, which is that the moment of upwards is equal to the total moment of downwards. We know that the moment is force times distance. it will be times perpendicular distance, right? It will be equal to the force 1 times perpendicular distance 1 plus the force 2 times the perpendicular distance 2. Now, question. We know that N is 1.43 newtons. Yes, so we can substitute here. 1.43 newtons multiplied by the perpendicular distance from what? From A. We know that A is the axis. I will go back and tell you why A is our axis. So for now, we know that A is our axis, okay? So what is the distance from the fulcrum, or from the force, to the axis? It is what? It is 45 centimeters. It is then equal to force 1, which we said is the weight of the ruler, which was 0.95 newtons, multiplied the distance from the weight of the ruler to the axis. We know that the weight of the ruler is in the geometrical center, is in the gravitational center. Since this object is uniform, it will be exactly in the middle. So since it is a meter ruler, which is 100 centimeters, it will be exactly in the middle, which is 50 centimeters. So 0.95 times 50 plus force 2. What is force 2? Force 2 is the second weight, which was 0.48 newtons, multiplied by the distance from it to x. So to find the distance from it to x, what are we gonna do? We don't have it, so we are gonna solve it to find it. So now we have 1.43 times 45 centimeters. We get 64.35. It's equal to 0.95 times 50 centimeters, which is 47.5, plus 0.48x. To find the value of x, move 47.5 to the other side. So 64.35 minus 47.5, you will get 16.85 is equal to 0.48x. And if you move 0.48 to the other side, you will get 35.1, which is approximately 35. So we found the distance, which is 35 centimeters. Now, we know is our axis. So if we were going to use the rule where moment of clockwise is equal to the moment of counterclockwise, you're going to use the right hand rule. So you're going to take your right hand. The inside of your hand has to be facing the axis A. So if you do it for example, the force N, you will see that your thumb is pointing towards you. If the thumb is pointing towards you, it means what? It is anti-clockwise. So we are going to put the force times distance of N, okay, in the anti-clockwise side. Then, if we're going to do it for the force W, we're going to do the right hand rule. We're going to see that our hand will be pointing towards the screen. Since it's pointing towards the screen, that means it's clockwise. So we're going to put the force W on the clockwise side. So it's going to be 0.95 newtons multiplied by the distance, which is 50. Or no, let me do force times distance of W plus. Why did I put plus? Because if you find the moment of force T, you use the right hand rule, you will see that your thumb is also pointing inside. So again, it is clockwise. So it's going to be force times distance of T. If you substitute it, you are going to have, so the force of N, if you remember, we got it was 1.43 multiplied by the distance of N, which is 45 centimeters, is equal to the force of W, which is 0.95 newtons multiplied by the distance of W, which is 50 centimeters, plus the force of T, which is 0.48 newtons multiplied by the distance of T, which is X. Then, if you solve it, you will get that X is 35 centimeters. So these are two ways you can do this. Question number 13. A boy uses a spanner of length 24 centimeters to tighten a nut. The moment of his pull, if he pulls at the right angles, meaning 90 degrees, to the end of the spanner with a force of 50 newtons, They need the what? They need it in newtons per meter. So to change from centimeter to meter, we are going to divide by 100. 24 divided by 100 is 0.24. Anytime they ever give you an angle, you're going to do force times perpendicular distance multiplied by the sine of the angle. So our force is 50 multiplied by the perpendicular distance, which is 0.24, multiplied by the sine of 90. If you do it on the calculator, you are going to get 12. So the value over here is 12. This is the moment of his pull if he pulls at a right angle. Now, if the angle between his arms and the spanner increased from 90 to 120, so what are we going to do? We're going to change the angle to 120, so it's going to be force times perpendicular distance times 120. Force stays the same, which is 50. The perpendicular distance is the same, which is 0.24, but it is now sine 120. If you do it on the calculator, you are going to get 6 radical 3, which is approximately 10.39, which is approximately, because they need it to 1 decimal place, it is approximately 10.4. Pay attention in the exam. If they ask you, how much did it decrease or how much did it increase, then you have to change. You should not put 10.4. You should do the initial one, the one with 90, which is 12, minus the one you got with 120, which is 10.4. But here they asked us what? They asked us the angle between his arm. No, they asked us, sorry, for the moment, not for the difference. Okay, so it's 10.4 newtons per meter. As a conclusion, it was originally 12 at 90 degrees. So if you increase the angle from 90 degrees, the angle results in a decrease in the moment. Now, the final question, a very, very important question, by the way. So, the adjacent figure shows a man of 90 kg. So the man is 90 kg. Walking on a uniform beam, meaning that the center of gravity is its geometrical center of mass 80 kg. So the beam has a mass of 80 kg. The beam is hinged at A. That means the axis, the fulcrum, is at A and hung at by B. Okay? By means of a cable. So this cable over here can withstand a maximum load of 1000 newtons. So something very important. Let's draw. First of all, we have the center of gravity. We have the weight of the uniform beam, which is 80 kg. Then we have the weight of the man, which is 90 kg. They're asking us, what is the maximum distance the man can move before the cable breaks? We know that there is a cable that's pulling upwards. The force is upwards. It's a tension force, okay? It has a maximum load of 1000 newtons. If you remember, the moment of clockwise is equal to the moment of counterclockwise, okay? You can do the right-hand rule to find the moment of clockwise is equal to the moment of counterclockwise, or you can do that the moment of up is equal to the total moment of down. So if we do that, the moment up is equal to the total moment down, we are going to get that force times distance perpendicular of up is equal to force 1 times distance perpendicular 1 plus force 2 times distance perpendicular 2 of down. If we substitute, we know that the force going upward is 1000 newtons multiplied by the distance from the axis, which is 6 meters. I don't know if you can see it here, it's 6 meters. Okay? Is equal to, we know we have the first force, which is the weight, the mass, of the beam. We know that mass is not a force, so we need to find the weight. Weight is equal to m times g. Here, let's use g as 10. Okay, so it's going to be the mass, which is 80 kg, multiplied by 10, okay, multiplied by the perpendicular distance. Since 80 is the mass of the beam and it's uniform, so the distance it's at the center of gravity, so it's going to cut it exactly in half. It's going to be the midpoint. So over here is going to be 3, and over here is going to be 3. So the distance from the 80 newtons, the force of the mass of the uniform beam, to the axis is 3 meters, plus force 2, which is the weight of the man, 90 kg times 10, times the distance that he needs. He needs to walk. We know that it can withstand a maximum load of 1000 newtons. So maximum is 1000 newtons. So if we solve it, it is gonna be 6000 is equal to 80 times 10 times 3, which is 2400, plus 90 times 10, which is 900, times the distance. So if you move 2400 to the other side, you get 6000 minus 2400 is equal to 900 times the distance. So 6000 minus 2400 is 3600. Okay, 3600 is equal to 900 times the distance. Move 900 to the other side, you get that the distance is 3600 over 900, which is 4 meters. So let's put 4, and inshallah ya Rab, there are no mistakes. Alright, thank you guys for watching. I hope you enjoyed. Thank God there were no mistakes. If you guys have any more questions, please message me. Have a wonderful day, and I'm sorry for the posting really late.